we have a point right here, 3, 4, right? That's all I know. That is all I know. I draw a line connecting the origin to that point. That line is always called a radius, okay? That's just what it's called. Now, do I know how to get to that point if I could just go horizontally and vertically? How much would I need to go horizontally to get to that point? 3. How much would I need to go vertically to get to that point? 4, right? So now, okay, would I be able to find, let's say, the sine of that angle? So here's the angle theta. Would I be able to find the sine of that angle? What would be the sine of that angle? What over what? It would be 4 over, okay, r. So what about r? Is there a way to find r? How would we find r? It's the Pythagorean theorem, right? So r squared would be 3 squared plus 4 squared. So r would equal to 5. So now r would be 5. Now, would I be able to find the sine of theta? Well, yeah, that would be 4 over 5, right? Would I be able to find the cosine of theta? That would be 3 over 5. Would I be able to find the tangent of theta? Well, that would just be 4 over 3. Now, let's look a little bit more closely at what these numbers are, right? Sine of theta is 4 over 5. What exactly is that? If I write this point, P, as x comma y, right? What's sine of theta really? Could I say that it's really that value y over r? Do you see that? And what's cosine of theta? It's just the x coordinate over r. And what's the tangent of theta? It's the y coordinate over the what? The x coordinate. Okay? So now, remember how in the beginning of this lesson, of this chapter, we did it the geometry way, and we said, oh, sine of theta is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So it turns out these terms, adjacent, opposite, hypotenuse, they're fine in geometry, but really in algebra 2 and on, they're not really as useful. What's more useful is, because I always have my angle oriented like this from the x-axis up, okay? What's the opposite side always going to be? If I say opposite side, is it always going to be the vertical, the horizontal, or the radius? It's always going to be the vertical. So opposite is always going to be the vertical. Well, then what's adjacent always going to be? Horizontal. Okay? Now, when you have an x-axis and a y-axis, what variable is the vertical side always? X or y? Is the vertical side always x or y? Y. And what about the horizontal side? Is that always x or y? X. So from now on, we're no longer going to say opposite and adjacent. We're now going to say the vertical or the horizontal, or y or x. Okay? So now, let's take a look at how we would find the trig functions of any random angle. So let's take a look at this angle here, okay? It says find the values of the 6 trig functions of theta if the terminal side is here. So now, what am I given? I'm given x and I'm given y. You can plot it. You don't really have to, but that's where 6 comma minus 2 is. And if I draw my radius to that, there it is. Now, the angle is always defined from the x-axis to the terminal side, between the terminal side and the nearest x-axis. So the angle theta is always that one. So when I draw my triangle, it's horizontal and vertical. All right? Now, is there any way I can find my value of the r? What did we say r was? R squared is x squared plus y squared, right? So if I take a square root of both sides, then r is the square root of x squared plus y squared. Here, r is the square root of x squared plus y squared. So now, r is the square root of x squared plus y squared. R is the square root of 6 squared plus negative 2 squared. 36 plus 4, which is root 40. What does that simplify to? 2 root 10. Okay? So r is 2 root 10. Now, let's see what sine of theta, cosine of theta, tangent of theta are. Okay, so I don't want you to memorize formulas. Remember, theta is always oriented like I've drawn it here. So, sine of theta will be that vertical side over the radius. Is that right? And vertical always corresponds with y over r. Okay? Is everybody okay with this? Now, if it's y over r, what's the y coordinate? If my coordinates are 6, negative 2, the y coordinate is negative 2 over 2 root 10. This is negative 1 over root 10. This is negative root 10 over 10. Okay? Cosine of theta is x over r. So that's always 6 over 2 root 10. 3 over root 10. 3 root 10 over 10. Tangent of theta is the vertical side over the horizontal side, which is y over x. So that's going to be, my y is negative 2, my x is 6, negative 1/3. Once you do that, now we need to find cosecant of theta, secant of theta, cotangent of theta. And remember, I'm going to take the reciprocals. It's easiest if I take the reciprocal of 1 over, okay, like the second to the last step. So here it'll be negative root 10. Here, root 10 over 3. And here, negative 3 over 1. Okay? Let's move on to quadrantal angles. Okay? Quadrantal angles are angles whose terminal side lies on either the x-axis or the y-axis. So suppose you have an angle of 0 degrees, right? That will be right there at that point, okay? 0 degrees, this is where we start, and we haven't rotated our terminal side, so that's 0 degrees right there. Now, if I put a point right there, let me put a point in purple, okay? Can somebody give me an example of a coordinate point that could possibly be the coordinate point of that point? 4, what? 4, 0 would be a possible one. Okay, so if that point was 4, 0, and if I were to draw that radius, that line extending from the origin to that point, how much would that radius be? 4, right? So R would be 4. Now, what do you think my favorite coordinate point is, do you think, for that one? What comma 0? 1 comma 0 is my favorite one here, right? Because 1 is such an easier number to work with. So if it was 1 comma 0, then how much would the radius be in that case? 1. Okay? So now, if I have an x coordinate and a y coordinate, and if I have an r, what would be the sign of that angle 0? It would be the vertical, which is y, over the radius, so it would be 0. Okay? No. Okay, so let's just fill that up. Let's just put in the chart here. So if my angle is 0, the sign of it would be 0. Okay, because at 0 I have a coordinate point of 1 comma 0. So what would the cosine be then? What would the cosine be? The cosine is the horizontal, the x over the r. Well, remember I said if my angle is 0 degrees, I have a point right there. And we said a common coordinate point over there would be 1 comma 0. Yeah. Okay. All right. So cosine would be x over r. So it would be 1 over what? 1 over 1, which is 1. Tangent would be y over x, which in this case is what over what? 0 over 1, which is 0. Now, cosecant is the reciprocal of the sine. So it's going to be 1 over 0, which is how much? 1 over 0 is undefined, because you can never divide anything by 0. Secant is 1 over the cosine, 1 over 1, so it's 1. Cotangent is the reciprocal of tangent, 1 over 0, which is undefined. Are we okay? Yeah. So let's do the one for 90 degrees. If my angle is 90 degrees, I am here, right? What's a reasonable coordinate point for that one? X is 0, y is 1. So how much would the radius be? 1, right? So here, x is 0, y is 1, and the radius is 1. Okay, so now, how much would the sine be? It's y over r, so it's 1 over 1. The cosine is x over r. 1 over 1 will just be 1. X over r, 0 over 1 is 0. Tangent would be y over x, 1 over 0, that's undefined. Cosecant is the reciprocal of the sine, so it's just 1. Secant is the reciprocal of the cosine, so it's 1 over 0, undefined. Tangent, look at tangent. It's the reciprocal, cotangent is the reciprocal of the tangent. So not 1 over 0, 0 over 1, so this is 0. Okay, now, let's move on to 180. 180 is here. What would be a reasonable coordinate point for 180? -1 and 0. 270 is here. What would be a reasonable point for 270? 0 and -1. All right, so -1 and 0, and 0 and -1. All right, so I'm going to stop this for a minute. I want you guys to fill in the one for 180 and 270. All right, so this is how we do the chart. Now, to summarize all this, to find the trigonometric values of a quadrantal angle up here, so determine the coordinates of a point on the terminal side. Use the formulas from the beginning of this lesson to evaluate, okay? And like I said earlier, the way I do it is if I wanted to find the cosine of 180 degrees, well, I ask myself, where is 180? Right there. I know that cosine is associated with the x. Here, the x value is -1, so this is -1. Okay? All right. If I wanted to do the cosine of 270, 270 is here, in the bottom. The x value there is 0, so cosine of 270 would just be 0. Okay. Now let's talk about reference angle, the single most important thing you'll learn in this chapter, reference angles. Okay. A reference angle is the acute angle formed by the terminal side of an angle and the nearest x-axis. Okay? And I repeat this because I can't stress it enough. The value of the reference angle must always be between 0 and 90 degrees. It's an acute angle. All right. So now, let's see some examples here. This is my angle here. So when I say reference angle, it's got to be between the terminal side, right? Where's the terminal side? I'll put the terminal side in green. The terminal side and the nearest x-axis. Now, I can go to the x-axis this way, or I could go to the left. Which one is closest? Going to the right. Right? That's the closest. So that's the reference angle theta prime. Now, what if your reference angle is here? Oh, I'm sorry. What if your angle is this? This is the initial side. This is the terminal side. From the terminal side, which is what color? Green. I need to go to the x-axis. I could either go to the right or I could go to the left. Which one's closer? Left. Go into the left, okay, to get to the x-axis. So that is the reference angle. We call the reference angle theta prime, okay? Yes? So if the terminal side is this red side, this is where my angle falls. Okay, now I need to find the reference angle. I can either go to the right to get to the x-axis, or I could go to the left to get to the x-axis. It's closer on this side, right, on the left, so that's the reference angle. Okay, next. Suppose your angle is in quadrant 2. Let's see, what would be a reasonable value for this? So suppose this angle was 150 degrees. Okay, now I need to figure out the value of that reference angle. Okay, so everybody tells you to memorize this stuff. Here's what we're gonna do. Cross it out. We're not doing any memorizing, because once you start memorizing this stuff, you fall into the loop of, oh my God, I forgot the formula. And we're not gonna do that because we're gonna understand what's going on. All right, so that angle is 150, right? How much would that reference angle theta prime equal, you think? 30? Does everybody agree with 30? Okay, so let's see. I agree with 30. Let's see why I agree with 30. So that angle is 150 degrees. That means from here to here, it's 150 degrees. Had I gone all the way here, how much would that have been? 180, but I only went 150. What was the balance that was left over there? 30 degrees. Okay, now let's do another one. Here it is in quadrant 3. In quadrant 3, this is my angle. So that's the terminal side. Now, The reference angle, I can either go up or I could go all the way this way to the x-axis, but that's too far. So the reference angle is this. All right? Now, suppose this angle was 210. Let's find that red reference angle. This much of it was how much? 180. How much more did I have to go to make it 210? 30 degrees. From 180 to 210, so that's 30 degrees. Okay? Now, let's take a look at quadrant 4. This is the angle, all right? It lies in quadrant 4. The reference angle is going to be up to the x-axis. All right? Now, suppose this angle was 300 degrees. All right? Had I gone all the way, that would have been 360. But how much did I stop short? 60 degrees. So that reference angle, theta prime, is 60 degrees. So that's how we do it when it's in degrees. How about when it's in radian? Here it is. In radian, the reference angle always looks like this, pi over a number, always. And that number, so basically, if the angle is 4 pi over 3, the reference angle is always pi over 3. So for example, what if the angle is 4 pi over 7? What would the reference angle be? Pi over 7. If it was like 5 pi over 6, what would the reference angle be? Pi over 6. Okay, it's as simple as that. All right, so let's do a couple of these. All right, let's do a couple. 330, I'm going to sketch it. Here, 330 is here. Okay. All right, the reference angle is this one. How much is the reference angle? How many degrees? Reference angle is 30 degrees. Okay, so it's 330. How much more would I need to go? Okay, so that's 30 degrees. In radian, how much is 30 degrees? All right, so what? Okay, how much is pi in degrees? 180, right? What would I have to do to 180 in order to get 30? 180 over what would be 30? 180 divided by how much? 18 divided by what is 3? 6. So 180 divided by 6 is 30. So this is pi over 6. Okay? All right, so look. 180 divided by 6 is 30, right? Since 180 is the same as pi over 6 would be 30. That's the shortcut to how to do it. Okay, let's do negative 240 now, and then I'll do the other ones. So negative 240, here's the initial side. Negative 240 is about there. Okay, reference angle, is it above or below? That's the reference angle. Okay, so let's see how much the reference angle is. From here to here, that would have been 180. How much more did I go to make it 240? 60. So the reference angle is 60. Okay, so I drew 240. From here to here, it's 180. I had to go an additional 60. Now, let's figure out how much this is in radian, right? 180 over what would give you 60? It's either going to be 3, 4, or 6. 180 over 3 would give you 60. That means it's pi over 3. Okay? Now, here's one more. Negative 5 over 4 pi. We're going to do negative. Okay, so 5 over 4 in mixed number is 1¼ pi. Okay. So here, we're going to go in the negative direction. 1 pi. This is how we draw them. We put them in mixed numbers first. It's the easiest way to do it. Okay? So, we're going to do negative 1 pi. That gives me that much of an angle. Then I'm going to go another quarter of a pi, which is right there. So that's where it lands. Okay? If you wanted to draw it. Now, we could have found the reference angle without even drawing it. If it's negative 5 pi over 4, what's the reference angle? It's what? Pi over 4. That's all. And how do I convert that to degrees? Pi is how much? 180. Pi over 4 is the same as 180 over 4, which would be 45 degrees. Okay? No, I found that it's the most efficient way to do it. Okay, so reference angle without doing anything. What's the reference angle for part D? Pi over 3. All right? Now, we want that in degrees. Pi is the same as 180. So if this is pi over 3, then it's 180 over 3, which is 60 degrees. Okay? Now, let's sketch it. 13 over 3 pi. That's 13 pi over 3. Okay, so how much is that in mixed number? 4⅓ pi. So 2 pi wraps around the circle. Another 2 pi gets me 4 pi wraps around the circle. Now I have to go another 1/3 of a pi to that point there. So it's in quadrant 1. Okay? Now, depending on where your angle falls, it can either, the sine, cosine, tangent values could either be positive or negative. What we do is we use this mnemonic. All students take calculus. It does not have to be a true statement. It just works, okay? All students take calculus. Here's how we do it. So it's all students take calculus. And remember in math, it's always counterclockwise. So look, it's all students take calculus. Okay, what is this business now? Okay, all right. You see where it says A? A means all are positive. That means sine, cosine, tangent, all are positive. S means only sine is positive. That means cosine is negative, tangent is negative. That means T is, which one is positive for T? Tangent is positive. Sine is negative, cosine is negative. C is cosine. Cosine is positive. Sine is negative. Tangent is negative. That means, this is what this means. If I'm in, this quadrant, if my angle is in this quadrant, like that, okay? And if I wanted to find the cosine of that angle, would it be positive or negative? It would be negative, okay? Suppose I had an angle in here. And if I wanted to find the cosine of that angle, would it be positive or negative? Positive. That's what that means. Now, the best thing in life ever, here it is. With this, we can find the trig values of any angle anywhere. So like you could be walking down the street and you see something like, the cosine of 120, and you could totally know what that is. Okay, I'll get you in a sec. Now, to evaluate the trig values of an angle, here's what we do. Find the reference angle. We can do that now, okay? Evaluate the value of the trig function of the reference angle. Determine the sine of the trig value using the chart above. Okay, it sounds a little confusing. We can do this. Let's do this first one. Okay? Sine of 135. Where is that? That's over there, right? 135. Okay. How much is the reference angle? 45. So what? Okay, so that was step one. I found the reference angle. Yes. Now, second one is evaluate the value at the reference angle. So that means it's asking me to find sine. I'm now going to find sine of 45 because that was the reference angle was. It would have been 180 minus 135, 45. So now, what's sine of 45? What's sine of 45? 1 over root 2. Root 2 over 2. Now, that's step 2. Step 3. In this coordinate, is sine positive or negative? So it's all students. Sine. Sine is positive. So the answer, sine of 135, is root 2 over 2. Yeah. Well, because the reference angle we found was 45. Okay? Yes. For homework, I would like you to do this, but just skip this one. 24 to 31. You can do the ones before and the ones after. Okay? All right. I'll see you guys next week.